Welcome everybody to the first video of our third unit here. This is Unit 3, Sensation and Perception. It's going to be coming right off of the biological basis of behavior. We're going to see a lot of connections here between sensation, perception, and biology. We will talk a decent amount about kind of the biology of our senses specifically, but we're also going to start getting into the things that are maybe a little less biological and a little more psychological. As we start looking at especially the perception side of things, okay? And we're really trying to pull these two apart. Now, there's kind of two things I want to start with, right? And one of them is just kind of one of the ideas about why this unit is really important, and why I think it's very important to talk about. And really, it's kind of this idea. And one of the things I'm going to try and, I don't know if I want to say convince you, but maybe kind of at least point out to you, is this idea. Much like where in our biology unit we talked about how everything you ever experience at the end of the day can be broken down into some sort of biological process, right? Some sort of electrical signal or chemical signal that's going on in your body. We can do very much the same thing with sensation perception. And one of the things I'm going to try and kind of push or convince you guys by the end of this is to see how everything you ever experience as far as sound or taste or touch or sight, right? All of these things that we use to understand our world that seem so real to us are really very much subjective understandings. And the reality is the world could be very different than the way that all of us as human beings experience it. So we're going to kind of be seeing that and kind of pulling that apart as we go through here. The other thing I want to mention is this picture that's actually on the very front cover here. What you might notice as you look at this is you might notice that it looks like it's very slightly spinning. And the reason I want to point it out is that this is actually just a static image. There is no movement in it. It's just one picture. And so one of the things we're going to use, and we're going to see these a lot as we go, is how we can use, especially like with vision, but how we can use different kinds of like little tricks to mess with sensation perception to kind of pull them apart a little bit. As we experience things, we experience sensation perception as one thing. We experience them at the same time all the time. So one of the things we're going to try and do is kind of pull them apart, mess with them a little bit to try and get an idea of what each one is. So that's what we're going to talk about here first, is just what is sensation and what is perception. Again, normally if you kind of ask just like a regular person, you probably kind of assume they're basically the same thing. But there's really a very big difference between them, even though they're really happening and working together all the time. So psychologically, when we're referring to sensation, we're referring to the raw information that we are collecting from the outside world and then taking to our brain. Okay, so obviously when we refer to our senses, these are all the things that are collecting that information. So our ears and are collecting sound, right? Our eyes are collecting visual information. Our skin is collecting information on pressure and heat, and maybe like texture, right? Our tongue is collecting information on taste. Our nose is collecting information on smell, right? We've got all these different senses, and they're collecting data, basically. Okay? Now, it's really important, and this is something that we're going to talk about as we go, is remembering that our brain is literally sitting just in your skull, floating in fluid. So your brain has no sensations. That's why, like when they do brain surgery, you may remember them mentioning that they just kind of like suction things out. It's because there's not like pain sensation in your brain, because your brain isn't supposed to interact with the outside world, right? So they don't have to worry about necessarily like you feeling pain in your actual brain. So what has to happen is all this information that's going on around us has to go from outside of our body and get to our brain. And that's what our sensation is. All right? It's the process of collecting information like a sound wave, turning it into a neural impulse, right? And then getting it to the brain so the brain can then do something else with it. So that's all the sensation side. The perception side is what happens once that information gets to the brain. So we've got that, that sound wave that came in. It worked with our eardrum, right? We're going to talk about that process a little bit later, right? It gets turned into a neural impulse. That impulse gets to the brain. the brain now has to interpret what that sound wave means. And this is perception. So the brain then takes this raw data and turns it into all of these other things, right? And there's kind of like two big things that we say is that it's going to organize it and it's going to interpret it. So it's going to put it together with other things, it's going to make connections, it's going to then interpret it to mean something. So an example of this is right now, you guys are all hearing me speak. Now, all sound is waves. It's literally just waves of basically particles and things hitting each other and causing a wave, right? And you can kind of see that right here in this little GIF in the corner, right? So it's these waves. So as I speak, all that's happening is my vocal cords are creating waves, right, that are then going out, and right now they're being collected by my computer. Your computer is then taking that information and projecting it to you, right? That's why if you've ever seen a speaker, it kind of like bounces, right? And if you have like the bass really high, you can feel the vibrations of that bass. It's because it's literal vibrations. So your ear then collects those vibrations. It sends a message to your brain that tells it what the vibrations are basically. And your brain then has to turn it into words and turn it into sentences and turn it into meaning. Okay? And I think it's really important. So again, that sensation part is the literal sound waves hitting your ears and your ears turning that into an impulse. Then our brain, the perception side, is our brain taking that impulse, taking that information and saying, this is words, this is language, this is what these words are, and this is what they mean. Okay? So that's kind of how we're going to divide sensation and perception. So again, raw information is the sensation side. The organization and interpretation of that information is the perception side. All right, so here's another example for us to kind of think about this a little bit. So in just a moment, I'm going to ask you guys to pause it, but I want you to do kind of two things here, right? So we're going to kind of think about this a little bit. So first, I want you to try and think about what is the sensations or what am I visually seeing in this image, okay? Now, I want you to, and this is tough, right? But I want you to try and think about, okay, what are the things that I see versus what are the things I perceive? So what are the things what are like the raw pieces of information that I'm getting? Okay, so I want you to pause the video right now. Well, in just a moment, I want you to pause the video and I want you to try and say, okay, what are the raw pieces of information that my brain would be getting? Okay, go ahead and pause it right now. Okay, so hopefully you've kind of paused it and thought about that for a little bit. Now, what I want to do is try and think of the other side. Okay, so as you've kind of been looking at this, hopefully the things you see, right, the sensation that you're actually receiving is very basic, right? Something like color, for example, right? That would be a sensation that we're getting. We're getting a different form of light wave that's hitting our eyes. You could even say something like some of the shapes maybe, right? Could be there, like the black lines, the outline, right? We can actually see those things. But what's important is knowing that you really are only getting kind of basic information as far as sensation goes, right? You're getting color, right? You're going to get these differences in color here. You get a little bit of like shape, right? Because you can kind of have lines around where things are, but it's very basic. There's no depth, and I think that's really important, right? Obviously, this is literally a flat image because it's literally on your computer screen. But we receive information flat, okay? So all of that is the sensation side. So the next question would be, okay, what is the perception side? So I want you to take a second, and I'll have you pause in just a moment again, and I want you to look at this and say, okay, if those are the things I'm seeing, what are the things that I'm actually perceiving? Okay, go ahead and pause it again. All right, so hopefully at this point you've paused it and unpaused. So what we should be perceiving here is going to be very different, right? And some of you may be looking at this and going, well, I see faces, right? And what's important is we're perceiving those faces, right? We are adding those in to this image, right? Because they're not technically faces. None of the things are actually faces in here. They're made up of rocks and trees and boulders and leaves and things like that. But we are perceiving them as a face. They've been organized in a way that we say that's a face. Even maybe the differences between like a rock versus the ground, right? What is it that really tells you which is which, right? How do you know where one thing is and one thing ends, right? We might say, okay, well, the color changes, but things can have different colors, right? So part of our perception is even adding in the outline of something, knowing this is one object, this is another, right? So the idea that, like, when we look at the horses, for example, right, you know that that is a man sitting on a white horse, right? You don't assume it's one object, right? It's not one thing. That's a perception thing. Okay, so it's really important, and why I use this image is I really want to pull out how much of what we see is perception, right? How much of how we experience the world is perception. And again, even that depth, the fact that we can see that there's like some parts that are closer to us, it's probably like the bottom, right? It looks closer than the top. Again, this is something that's completely flat. So we are perceiving it as having depth. Okay, and we're going to kind of talk about these different perceptive cues and how we kind of interpret things in our next video. But again, it's just pointing out this separation between the two. The next thing you do, if you want to pause it again really quick, is try and find how many faces are in this image. How many faces are there? The cowboy doesn't count. You can't really see his face. But how many images or how many faces are in here? Okay, if you want to pause it again, go ahead and do that right now. I'll wait a few seconds and then we'll move on. Okay, so here we go. Moving on. So here are actually all the faces. There are 13 of them, right? Let's kind of see how many you could find here, but they are circled here. So here are all the faces. Now again, remembering that these are interpretations. This is literally a tree, right? But when you look at it, you can perceive it as a face, right? So pulling those kind of pieces apart again here. So let's talk about processing a little bit. Now, there's basically two ways that we process information as far as sensation perception goes. There's bottom-up processing and top-down processing. So we're going to start with bottom-up. So bottom-up processing is where we detect physical energies, right? So again, light is waves as well. Sound is waves, right? Temperature is kind of sensed through those molecules of heat, right? So we're sensing physical energies. Everything we sense has to do with energy from our environment. And then we are encoding it as neural signals. So again, you can think of that sensation side of things. Now, this is just the basic understanding of something. So when we see something or hear something, we don't know what it is, right? That is bottom-up processing. We use this again when we don't have prior knowledge. So we don't know what it is to start. We start at the bottom of, again, these basics of what are we literally seeing or hearing or experiencing, and we work our way towards what is that thing. Okay, so we have an example here, right? This image right here. And when you look at this, right, the question is, what is this? Right? What is that symbol? Now, you probably broke it down to two basic answers, right? You might say it's a 13, right? Here's the 1 and here's the 3. You might also say it's a B, right? The letter B. The question is which one is that, right? So this is an example of bottom-up processing where we're literally looking at this thing and the way we're experiencing it is just from the basic sensation, level. We don't know, we can't necessarily apply what it is. So let's keep going. Now, we're taking the same example. Let's actually start with our example here, right? So this is top down. So now I've added context basically. That's all I've done. Right? The symbol itself is the exact same. But it probably becomes very clear in each of these examples what it is in the middle. Right? Here, it's obviously 12, 13, 14. Right? And when you look at it, you go, oh, it looks like a 13. Here, it's clearly A, B, C. And it looks like a B. Right? Now, again, this is the same exact images we saw before. These are the same exact images as each other. But when we add in this context or we add in this prior knowledge, it kind of almost changes a little bit what it looks like, right? You can clearly kind of see what it is. So again, our top-down processing, right, again, is kind of the opposite of our bottom-up. Bottom-up works from the very sensation at the beginning. We try to work towards understanding it. Top-down is where we're going to take organization, right, take things we already know and apply them to the world, right? So the mental process of organizing sensory input into meaningful patterns. All right, it's our way of making sense of the world. So again, when we have this pattern, this becomes clear. When we have this pattern, this becomes clear. And that's kind of the idea. We're taking these things and we're adding it and making things meaningful onto this. We process this way when we do have prior knowledge, right? We start at the top, we start at the pattern, and we work our way towards the details of the specific thing. All right. Again, this is why you can do things where it's like I can give you 4 numbers and leave one out, and you can tell me what that number in the middle is, right? Because we can look for those patterns and apply it into that section. Here's another example. So what I want you to do is, again, in just a moment, pause it, and I want you just to read this aloud. Okay? So go ahead and pause me now. Okay? Hopefully you've unpaused here and you've gone through and you've read this image aloud. Now, or I guess this sentence aloud. Now, what's really important about it is as you were reading, it was probably very easy for you to read, right? Unless maybe like, I don't know if one of you has like dyslexia or something, that might obviously make it harder. But as you went through it, you probably didn't really even stumble very much at all, right? According to research at Cambridge University, it doesn't matter in what order the letters in the word are. The only important thing is that the first and the last letter be at the right place. Now, what's really interesting here is, again, if you think about, okay, how, or at least on a basic level, you'd probably go, you shouldn't be able to read this, right? It's jumbled. All these letters are completely mixed up. How can we figure out what it is? And what it tells us is, again, about this top-down processing. When we read with top-down processing. We don't actually look at every letter of every word, right? We actually are looking at one word at a time, right? We're looking word, 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 word. So when you look at it all together, as long as certain parts are there, so as long as the first letter is there, the last letter is there, and all the letters in between are there, even if they're mixed up, we can tell what that word is, right? That's why, like, if you've ever read something by like a little kid, or maybe someone who just has really bad spelling, even when they spell things wrong, you can read what they're writing. And again, that's because how our brain is processing. It's processing from the top down. So it sees certain things and it's applying that information to it, even though the sensation maybe doesn't necessarily fit it. That's going to get us to selective attention. Selective attention is really important, and we're going to actually watch a few different kind of videos that mess with selective attention in class. What it basically is our how our awareness focuses on a small aspect of our experience. So our senses are always collecting information every second of every day, all the time. They're always working. And realistically, like even when we're sleeping, they're working, right? So the problem is that can be too much information, right? We actually know that our senses take in about 11 million bits of information every second. Okay, and again, that should kind of make sense if you think about it, right? Your ears are always listening, your eyes are always looking at something. Even when you close your eyes, you're still actually getting information. You're just getting the information of the inside of your eyelids. That's right, if you're in a dark room and you close your eyes, it just looks black. But if you're in like a really bright area and you close your eyes, you can still like kind of see light. Your eyes are still going, they're just seeing the inside of your eyelids, right? Our skin, every sensor all over our entire body that's detecting heat or pain or cold or pressure or texture, right? All of them are working all the time. So our brain technically is getting 11 million bits of information every single second of every single day of your entire life. But we only process about 40 of those consciously. So we only actively acknowledge about 40 pieces of those information consciously. And this is what selective attention is. Selective attention is basically what bits of information are we consciously aware of? Are we actively paying attention to? All right. This is why, right? If you've ever been in like a really boring class, I think is a good example, right? You've been in a really boring class and maybe your teacher starts talking and they're going and going and going and you're like, I don't really care about calculus. It's really boring or whatever. And maybe you're like looking at something and as you're looking, like their voice kind of like fades away, right? And you don't even notice it anymore for a while. That's selective attention. Is basically, even though that sound is still coming in, you're focusing on that perception, right? You're focusing on something else. So that piece of information kind of goes away. Now you're still listening, which is why, and we cover this somewhere else as well, which is why is even when you don't hear anything, you suddenly hear your name and you like snap back and you're like, oh, yeah, I'm paying attention. That's because our ears are technically still hearing it. We're just not consciously processing it. Okay? Selective attention, super, super, super important. One of the classes, and I can't remember which one it was, somebody asked about kind of like the idea of like the movie Limitless, right? Where it's like we're unlocking all of our brains. And one of the things that's really important is actually if we were able to consciously apply our brain to everything, it would actually be horrible. And this is why, right? If you had to consciously think about 11 million pieces of information every single second, right? It would entirely overwhelm you. You wouldn't be able to do anything because you would just be bombarded with information all the time. So it's actually a very useful trait. We're going to watch this video in class. It's really interesting, but it's Apollo Robin, who you may have seen in like brain games. He's on a lot of brain games, but his whole thing is he's basically messes with attention, right? And so he can kind of use attention to show how we can't pay attention to everything. Okay, so we'll watch that in class. We're also going to do another thing here where we're going to kind of test your guys' attention. We'll do this in class as well. So let's talk about a few other pieces. So when we look at attention, there's a few things that we can see based on, right, how we can mess with it. One of them is inattentional blindness. The other one is change blindness. So what are these two things? So inattentional blindness is basically the failure to see visible objects when our attention is directed somewhere else. So it's basically like if I'm paying attention to one thing, I'm going to fail to see something else, right? Because I'm not paying attention. Okay. Now, again, we're going to kind of play with this stuff a little bit in class, and we'll kind of show you an example. But the idea is, again, like if we're like focusing on one thing, it's hard. I can't focus on something else, right? And so I'll miss it. I won't even see it. Now, this is, again, focused on something visual, right? If I'm looking at something, I'm not going to see something else. Same thing here with change blindness. So change blindness is basically the idea that we won't notice changes in our environment, right, if we're not kind of paying close attention to it. All right, so we can change a part of the environment, right, and we might not notice. Okay, now we're going to watch a video here where we're going to show that. This is actually a little clip from Brain Games where they're basically going to put people in an environment, change that environment, and then see if those people notice the change. And again, what we're going to see is there's only very specific ways that we notice it, right? If we're looking right at it change, yeah, we're going to notice. But if we're not watching the change happen, if it's happening kind of like behind the scenes, we don't actually see the difference. Okay, and again, the idea here is where it's all about playing with attention. How do we focus? Where's our focus? And I think too, one of the things that we really want to point out is how much we actually miss. Because I think we only experience what we experience. So we assume that we notice everything. We assume we hear everything or see everything. And the reality is there's a lot of stuff that we don't even realize is going on that we're just not paying attention to. So let's keep going here. So those are a little more, attention is a little more of like the perception side of things, right? Let's talk a little bit about the sensation again. So what do our senses actually do? And the big thing that they do is what's called transduction. Okay, transduction. So this is actually what's happening in our ears, our eyes, our tongues, our nose, our skin, right? This is what's actually happening, is this process of transduction. And this is a pretty important term. This is one that they tend to ask about at least somewhere every single year. So what transduction is basically the process of converting one form of energy into another. So like if you Google transduction, that's what's going to come up. And we can talk about transduction as far as like chemistry or physics, right? But those terms are connected there. For us, right, for psychology, we care about how do we take energy from the outside world and turn it into something that our brain can understand, right? And that's what that second part is. So how do we take, for example, light energy, visual light energy, and turn it into what we see? How do we take sound energy and turn it into what we hear? Okay, that's transduction. Now again, what's really important is our brain cannot see, our brain cannot hear, our brain cannot feel. So we have to take that information and we have to use transduction to turn it into something that our brain can understand, right? So there's 3 basic steps here, 1, 2, and 3. So the first step is that our sense organ receives sensory stimulation. So if we want to use sound as our example, right, your ears are hit with the waves that make up sound, right, and it stimulates the sensory organ there. So here our eardrum, for example. Now again, there's a whole bunch of different receptors that can do this, but they're going to be stimulated in a certain way. The second step is we have to turn that stimulation, right? So this example, the sound energy, the waves that are literally hitting your eardrum, into a neural impulse. So there's basically all these little steps. We'll talk about them specifically later on in this unit, where it basically goes through all these different things, and then it gets turned into neural impulse. That neural impulse then has to get to our brain. Now again, our brain understands neural impulses. That's how it works. So that neural impulse gets to the brain, right? It goes to all the different parts of the brain that needs to, and it gets interpreted, and then we hear sound, okay? Whatever sound that it is. So again, those are our 3 steps: receiving the information, turning the information into a neural impulse, sending that neural impulse to the brain. So that's going to get us to kind of a few more pieces with sensation. So there's also kind of limits to our senses, right? So there's kind of 2 big ones that we're going to talk about. The first one is what is called absolute threshold. Now, what absolute threshold is the minimum stimulus energy needed to detect a particular stimulus 50% of the time. Now, that's kind of a wordy definition. It sounds a little weird. Very basically, it's the idea is what is the absolute minimum thing that we can sense. Okay? Now, they do it 50% of the time, so it's basically like half the time we'll sense it, half the time we'll miss it. It's basically the limit of our sensory abilities. So, oops, I didn't mean to go over. So, oops, where am I? Okay, here we are. So again, here's a little chart. Now, you may want to kind of know these. Usually, it's a little tricky. So sometimes they'll want you to like know the specific things. As long as you have a pretty like decent idea of it, or at least a pretty good guess, they're probably not going to ask you a question to know like the exact amount, right? So like they're probably going to not ask you to know, okay, how many miles away can we see a candle flame? Like they're probably not going to ask that, but they'll want you to have like a general idea of kind of what these thresholds are. So for sight, right, the absolute threshold. Now again, technically this would differ person to person. So these are kind of like averages over human beings, right? So for sight, our absolute threshold is a candle flame at 30 miles on a clear, dark night. So if you have 30 miles away, a clear, dark night, and you have a candle flame, that is the absolute minimum that we could see half the time. For hearing, it is the tick of a watch. That's why I have this little watch right here. The tick of a watch 20 feet away in a quiet room. For smell, it is 1 drop of perfume diffused through a 3-bedroom apartment. For taste, it is 1 teaspoon of sugar in 2 gallons of water. And for touch, it's a bee's wing falling on the cheek from 1 centimeter above it. Okay, now again, the idea of these is this is the absolute minimum that we can sense. Anything that's less than this, we literally just won't even pick it up. Our sensory organs won't hear it. So anything like if a watch was ticking and it was 30 feet away, your ears just literally won't pick up that information. Now, obviously this differs with like different animals, for example, right? Like dogs would have a much lower absolute threshold than we would because they can hear a lot better than us. Right? So this would kind of change. But that's the idea, and really what we just care about for us is humans. So that's going to get us to difference threshold here. So difference threshold is similar to absolute threshold, but it's about the difference. So instead of it being the absolute minimum that we can detect, it's the minimum difference between two different stimuli. Okay, so the minimum difference between two stimuli required to detect 50% of the time, again half the time. Okay, so what we experience it as, or how we would maybe word it in like a little bit nicer way, is what is called just noticeable difference. So let's say, for example, we have a light, right? And we're slowly, very, very slowly turning that light up, right? We're slowly making it brighter. Just minimum difference, or I'm sorry, just noticeable difference, or the difference threshold would be what is the minimum amount that it has to get brighter before we notice that it's brighter. Okay, so it's basically a little bit less of like how low can it be, but how accurate are we? How easy is it for us to see change? Okay, now you may notice when you look at this that these are all percentages, and that might seem odd, right? Because in our other one, it's kind of like it's not like a specific number, right? It changes its percentage. So as these get bigger, so the brighter the light, the more it's going to have to change for us to notice a difference, as opposed to a dimmer light. And the reason for that is what is called Weber's law. So Weber's law is, it says, for an average person to perceive a difference, two stimuli must differ by a constant minimum percentage. Constant minimum percentage. Okay? And what this means is that depending on the stimulus is going to depend on how much literal change there is. The percentage change is always going to be the same, but the actual difference in the stimuli would be different. Okay? So for light, it is 8%. For weight, it is 2%. And for tone, it is 3%. All right? So here's kind of an example, right? So these are our lights, right? And let's say it's going up, that each of these little bulbs is it increasing the brightness by a certain number, right? I'm just making that up. I don't know what number it is. But it's going up by the same amount. So you notice when we look at the first 4 lights, right, really the first 5 lights, we notice a difference each time it goes up by that number. But as we get into that brighter part, even though it went up, we don't actually hear a difference there. Right? We don't actually hear the difference. We don't actually see the difference in the lights, right? That's where it says no, right? We can't actually see the difference. Even though it got brighter, we're unable to perceive it. Now, again, it's because of that 8%. So at small levels, 8% change is not a lot of change, right? But we're going to notice it. At higher levels, the brighter something is, for example, it has to be more change for us to notice it. Another good example of this, and actually I want to see what's on my next slide. No, it's not what I want. Okay. Another really good example of this is with sound. So, and there technically could be other reasons, but I think this example still works for us. So like when you're in a car, right, and you're driving, and let's say the music's all the way off, right? And you turn the little dial up. Let's say you turn it up 2, right? There's 2 little ticks, turn it up, right? You probably immediately notice a difference between 0 and 2, right? Now, if you turn it up 2 more, right, you probably still notice a difference, right? 2 to 4. Now, as you keep doing that, what we're gonna notice is that at the beginning part, it's really easy to notice the difference. But as you go, right, let's say you get it all the way up to like 30. I don't know how hard. Let's imagine they go up to like 50, right? You've got it up to 30, so it's pretty loud, right? And you turn that 30 up to 2, so you turn it up to 32, you might not actually notice a difference, right? And the reason, again, is that the higher that amount is, right, the bigger that change is going to be, because 3% got bigger. Okay, and that's kind of the idea of Weber's law, and that's the idea of difference threshold. So that gets us to what is called sensory adaptation. So this one is pretty straightforward, right? How our senses adapt. So basically what we know is that our senses become less sensitive. They become less sensitive when there is constant stimulation, right? So diminished sensitivity as a consequence of constant stimulation. So a really good example of this that you may be experiencing right now, and I'll actually give you a few different examples, right? And what's going to happen is, as I point these out to you, you're going to notice them a little more, right? So right now you probably don't notice them at all, but as I point them out, you're going to start noticing them. So one example might be the fan on your computer, right? Right now, you probably hear it because I just brought your attention to it. But, right, you probably haven't really like paid attention to it at all throughout this entire lecture, right? You may have noticed it at the beginning when you were first kind of turned it on, or first like the fan first turned on, you kind of noticed it, right? Or if it kicked up really quick. But since then, it's probably been a pretty constant sound. And because of that, right, basically that stimulation has got less and less, there's less and less sensitivity to it, so we pay less and less attention to it. Now, if suddenly your fan like kicked on super high, right, because that sound changed, we would pay attention to it, we would notice it, right? Another example is right now, if you're wearing socks, the feeling of those socks on your feet, right? Again, if you've been wearing socks all day or shoes all day or whatever, you probably notice them. You probably forget about it, right? When you put shoes on in the morning and you walk around all day, you don't really notice your shoes unless there's something uncomfortable about them, right? Again, the idea is that our feet are feeling the sensations, whatever it is, hot, cold, the texture, right, all the time. But as that sensation, as that neuron fires over and over and over and over and over again from the same sense, right, it basically gets diminished. So what's actually happening here is if a stimulus remains unchanged, our nerve cells fire less often. So actually what's happening is that sensation that's coming in through our ears or through our feet, right, that neuron is literally firing just less and less often, right? At first, when you first put your shoes on, when you first get dressed in the morning, when you first hear a sound or see something, our neurons fire a lot, right? When you first put on your socks, you feel them right away, right? And your nerves are firing a whole bunch. After an hour, right, where that same sense has been happening, right, they're firing less and less and less and less, so we notice them less and less and less. Now, this is actually a really useful trait, and the reason for that is what it allows us to do is more easily focus and spot changes. So if you think about it this way, sound is maybe, I think, the easiest example, right? Imagine you're like out in the wilderness and you're walking around, and you can hear, the sounds of nature, right? After a while, those normal sounds of nature, like let's say like birds singing or chirping or like crickets or the wind, right, kind of fade away, but we'll notice a change. So all of a sudden you hear the crack of a stick, right? That becomes very noticeable because it's different. We're not being overwhelmed by the noises that have been there for a long time, okay? And that's sensory adaptation. So it's, again, over time, the sensitivity of our sense organs are diminished basically when we hear a constant stimulation, when we have a constant stimulation. Okay, so this is the last little piece to wrap up this video. It's a little long one, but I think it's a really useful quote, and we'll kind of talk about it a little bit in class. So what it says is, we perceive the world not as it is, but as it is useful for us to perceive it. And I think this is something that, again, we're really going to kind of mess with next time I see you guys, is starting to understand that what we see, what we hear, what we taste, what we smell, isn't necessarily reality. It's what parts are useful for us. Okay, what makes sense for us to survive. Okay, so that's going to wrap up our very first video on sensation perception. Go ahead, do a quick summary, a few sentences in your notes, and I'll see you guys next time.